Halo Dr. Mukesh.
Hello, how are you?
Fine. Long time no see you, doctor.
Yeah. After a long time, we are meeting over here. So, how are you all? Hi,
Great.
Chris. I think I can see the Chris also. Anna.
Yeah. Mr. Presenta is our special guest today, doctor.
Okay. Thanks, everyone.
Masih mood, Pak. Suaranya.
So,
Okay.
Chris,
How are you, Dr. Mukesh?
hi,
It's long time not see
hi,
you.
Chris. Fine. How are you?
How about Thapar? I missed
Yeah.
want to visit the Thapar again.
After a long time, I am seeing you here.
Yeah, if the condition is well, I also invite you to come again to our university. Maybe we can to go to around the West Sumatra, like to see to the mountain.
Right. Surely we'll go ahead, Anna. Once the situation is good, post-COVID situations, if this situation is good, we can again come and visit the Indonesia. Beautiful Padang, beautiful Indonesia, Anna. So we can go once the situation is fine.
so how's pandemic there, doctor?
Yeah, it is not bad. It is not so bad, but the effect is there. The pandemic effect is there. In India, every day, 1 to 2 lakhs cases are there. But this time not so severe.
How about Omicron, doctor?
Yes.
Omicron.
Yeah, Omicron is not severe here. Not so severe here. It is not in a bad conditions in India. So I need to start or something we have to wait for?
Yeah, we're waiting for sitting editor of Teknomekanik Journal, Professor Syahril. Sudah boleh kita mulai, Pak?
Silakan. Halo, terdengar suara Sari?
Shall we start, doctor?
Sari,
Terdengar,
halo?
Pak?
Jelas ya?
Ya, Pak.
Suaranya jelas?
Jelas, Pak.
Oke.
Shall we start, doctor?
Okay, we can start.
Halo,
Yeah.
Dr. Mukesh.
So,
Yes, sir. How are you, sir?
Fine. And you?
Yeah, me too, fine. And nice to see you all again after after 2 years long gap in this pandemic.
Okay, thank you. Let's go. Sari, start.
okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen. It is my pleasure to welcome you to the 5th International Symposium with topic Electric Vehicle and Industry Revolution 4.0 that organized by Teknomekanik Journal. My Honorable Sitting Editor of Teknomekanik Journal, Professor Syahril, PhD. My Honorable our keynote speaker, Dr. Mukesh Singh from Thapar Institute of Engineering and Technology, India. And my Honorable for special guest, Head of UNP's Research Center, Mr. Krisma Dinata, PhD. And thank you for all participants have joined the 5th International Symposium today. Our participants come from several countries, the Republic of Kazakhstan, India, Malaysia, and Timor-Leste. I will inform you that this international symposium being live streaming in Teknomekanik YouTube channel now. First of all, I would like to introduce myself. My name is Rizky Emma Wulansari. I'm a moderator and I will lead this symposium and our discussion today. So before keynote speaker presentation, let's start with opening speech by Chief Editor of Teknomekanik Journal, Professor Syahril PhD.
Okay, Sari, thank you.
Professor Syahril PhD, yes, the time is your prof, please.
Thank you, Sari. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. The Honorable to Rector Universitas Negeri Padang, Dean of Faculty Engineering, Dr. Fahmi Rizal, Head of Mechanical Engineering, Mr. Purwantono, special our speaker, Dr. Mukesh Singh from Thapar Institute of Engineering and Technology, India. Thank you, Mr. For your sharing your knowledge, Zen, and all respectable attendants. Ladies and gentlemen, please let us to Allah who have given us this blessing, so that today we can see other virtually here to join this event. I give my big thanks and respect and appreciation to the committee who has worked hard to hold this symposium. This event is the 5th International Symposium, which is presented by Teknomekanik Journal, organized by Department of Mechanical Engineering, Faculty Engineering, sponsored by Research Center, Universitas Negeri Padang. For your information, it's an international journal week dedicated to the improvement and dissemination of the knowledge on method, policies, technologies, and technical science and engineering education. It's welcome contribution from all who wish to report on new development and latest finding in engineering, new trend, and progress profit practice in list file and creating the unique forum for interdisciplinary and multidisciplinary knowledge. Teknomekanik Journal published 2 issues a year, and it has been indexed by Sinta for Google Scholar, Garuda, and Dimension. So, for everyone who has qualified article with this area, please send to Mechanic Journal for publication. Ladies and gentlemen, this symposium will be have outstanding speaker from Thapar University, from Thapar Institute of Engineering and Technology, India. Dr. Mukesh Singh will be present his paper entitled Electrovehicles, development of passive battery management system at TRL4. This paper contain update knowledge, so we can get new input and understanding from it. So everyone, please follow this symposium well and take a good advantage of the question and answer session. Last, I am the editor-in-chief of Teknomekanik Journal. One more, would like to welcome to you all to this international symposium, and we wish this event will be benefit everybody. Now, officially open this symposium by saying Bismillahirrahmanirrahim. Thank you for all. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for Professor Shahalo PhD. And that one presentation by keynote speaker, Dr. Mukesh Singh from Thapar Institute of Engineering and Technology, India. So Dr. Mukesh, you have 1 hour to present your article. The time is yours.
Thank you. Thank you. Thank you. So I'll share the screen now, and so hope my screen is visible to you all.
Yes, Doctor.
Okay. Okay. So the topic, there is a good afternoon. So in Indonesia, I think it is afternoon, and in India also it is afternoon. So good afternoon, everyone. And good afternoon, Rizky, Emma, and Sharil, editor-in-chief, for allowing me to present my topic. Okay. So I'll straightway start the discussions. And I have been to Padang 2 years back, and it was a wonderful visit. And I love Padang very much. And Chris and other team has honored me there for a 4 to 5 days of visit, and it was a very pleasant stay there. So based on that, I'll start my discussions, and my topic is electric vehicle, and how electric vehicle is going to be in IR 4.0. Okay, 4.0. So that is the major part of my discussions. And I will start with a very fundamental, where you can understand. So I'll go very slow, and whenever you are having any doubt, you can message in the chat box, and I love to help you, and I'll try to make this discussion very fruitful. So the topic of the discussion is passive BMS, that is called passive battery management system. Okay, so that is the development of passive battery management system. Now, about myself, I have given here a brief bio sketch. I have done my PhD from IIT Guwahati, India. I am having a passion in teaching, and I am having a 12 years in active research. About my publications, I am having 100 research publications. Okay. Out of this 100 research publications, 27 research publication is in IEEE transactions, and 35 publications in international conference. I have been awarded Engineer Guru Charan Singh by Punjab Science Academy, India. I have been awarded Best Teacher in many of the times. I am the keynote speaker in 10 to 15 international conference abroad physically. I have been awarded 3 times PIS in research, and recently I have been elevated to IEEE senior member. I hope my sound is audible to you all. My sound is audible, please. Uh, Sorry, my sound is audible.
Yes, doctor.
Okay, 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 okay. So this is my research profile. So I am having a research collaborations. Okay. So NTU, NU, Norway, Ryerson University, Canada, University of Malaya. So these are my research collaborations. This is my research area where I make my research on lithium ion battery, then battery management system, charge controller, okay, for higher power rating battery, fast charging, and state of charge and state of health estimations. So these are my specific area of research. Then my research interest include smart grid, then renewable energy sources and electric vehicle. My major breakthrough is you can see that I have developed a net meter for vehicle to grid. That is a global research which I have made it, and it has been developed in the lab of Thapar Institute of Engineering and Technology. Then I am having a sponsored projects worth 2.6 million USD, which is taken from DST, Department of High Industries, CSIR, and many more companies, industries. So this is my brief research profile. Now, going background to these research topics, I'll say you that in world, the electric vehicle is going to emerge like anything. So electric vehicle is going to grow in future. And when electric vehicle is going to grow in future, the research related to the electric vehicle is also going to rise in many folds. So just you see here that in 2010, okay, this much vehicles were sold in India, and now see how much vehicles, how it is exponentially increasing it. So all countries are very much interested to promote the electric vehicles. So electric vehicles, you can see that all the government of all countries are supporting the electric vehicles. So this is the Fame India by India. So similarly, there are different countries. You can just see that how the globally the China is leading, then US is the second leading, Norway is the next one, Japan, France, Germany, and India is very low. Similarly, I don't have the figure of the Indonesia. So there is a electric vehicle research has started throughout the world. Now, if you see this figure is that we have developed a e-cart, that is golf cart, in India and Thapar University, Patiala. This is the campus of the Patiala. You can see here, beautiful campus. And here, this whole cart has been developed in Thapar University. Okay. So if we see about the electric vehicle is divided into majorly 5 parts. One is having its battery, okay, which is the driving force. Then another is your battery management system, which is the brain of the battery. Then the battery has to be charged, so we have to develop the charger. Then we have to have a motor and controller which can control the drivetrain, and then the metering has to be there. So my research area is focused on this 5 parts: battery management system, charger, motor controller, and net meter. Okay, so this net meter we have made it ourselves, and that is at TRL 9 level, and we are going to make a technology transfers for selling to the customers. So this is the achievement we have done it in Thapar Institute of Engineering and Technology, Patiala. Now, if we say history of electric vehicles is not new, okay, nowadays we are using electric vehicle, but history of electric vehicle is not new. First electric carriage was developed in 1834. So if I say that electric vehicle is new, electric vehicle is not new, electric vehicle is very old, but the technology was not developed that time. So in 1834, then in 1859, first rechargeable battery was invented, that is called lead acid battery. Everyone knows about lead acid batteries. So first rechargeable batteries was lead acid battery, and that was invented in 1859. First electric car by Thomas Park and by Rope was developed in 1884. Okay, so you can see that electric taxi fleets introduced in Paris and New York in 1887. Before 1887, in 1886, first gasoline cars were invented, by Carl's Bench. So gasoline means what? You are having a petrol or diesel. So this car. And from there, it started. So we are shifting between the gasoline to the electrical, gasoline to the electrical, and so on. Okay. And finally, the lithium ion cells, which we are using in our mobile phones, okay, or in the laptop battery, that was invented in 1980s. And from there the electric vehicle uses has started, and the people has thought that battery is one of the major role in developing the electric vehicle. So this is the history of electric vehicles. So hereafter we can say that electric vehicle is not a new, it is very old, but we need to develop, we need to make more research on the technological front to make the electric vehicle to be a successful one. Now, history of battery. Okay, so this is very interesting. So if you see the history of the battery, you will find that the in Baghdad battery was developed in 2050 BC. So battery is also not a new one. It is developed in 2050 BC. That is called Baghdad battery. Then in 1749, Benjamin Franklin first coined the term called battery. Okay, and he developed this battery. So similarly, in 1800, the first true battery was invented. Secondly, I told you that in 1859, first lead acid battery by Gaston Plant was invented. And from there, the battery system started. Now you can see that lithium iron phosphate, this is in 1996, and LFP battery was developed. So if you check your mobile phones, and if you open your mobile phones, you will find that there is a LFP battery is there, and lithium ferrous phosphate or lithium iron phosphate battery, you will find it. Then more advanced battery, NMC, you can just see here NMC battery is there. So NMC battery was invented. Okay, and this is also used nowadays in Apple mobile or Apple batteries or Samsung or many or more devices. So these are the things you can see that there are different stages of the battery. So what we understood from here, that my battery is not new. It started in 2050 BC. Okay, and we are now at this positions. Now we'll go back to the next slide. Okay, so I'll start with the electric vehicle. So electric vehicle is can be given based on the technology. It is having PHEV, plug-in hybrid electric vehicles. Then battery electric vehicles. So two types of batteries are there. So plug-in hybrid electric vehicles and battery electric vehicles. Okay. Then types of EVs, there can be passenger cars, there can be commercial vehicles, there can be e-rickshaws, there can be two-wheelers, there can be three-wheelers. So these are the type of electric vehicles. Charging place, you can charge at home or office. Okay, you can charge at home or your office. You can charge at private or public outlets, or you can also charge at commercial places. Now, types of charging, you can make a slow charging, you can make a fast charging. Okay, so hope my sound is audible to everyone, and my sound is audible to everyone. And if any doubt, please do ask me any questions, or whether I don't know my English, you are able to get it or not, because my accent is something different. So hope you will be enjoying my lecture. So any doubts so far here, or shall we move ahead?
Yes, move ahead, Doctor. We have a question and answer after this session.
Okay. So I should move ahead, no?
Yes.
Okay.
You should move ahead, Doctor.
So this is the battery technology. So we are having a geometry. Okay, geometry. So there can be a cylindrical type, there can be prismatic type, and there can be pouch type. Okay, so this type of cells, you might have seen it, and this is the prismatic type. Already it is put in the electric vehicle, and this is the pouch type, which are kept in the inside the laptop or the mobile phones. Okay, so these are the chemistry composition of lithium cobalt oxide, lithium iron phosphate, lithium titanate, and lithium manganese oxide. So these are the different battery compositions. Okay, now I'll start with my topic, which I told you, that battery management system. Okay, what is a battery management system? So if you see here, battery management system, so you can see that the fire has occurred, okay, inside a electric vehicle. So this is due to the lithium polymer batteries needs a battery management system, which is nothing but it is a protection circuitry. Okay, and it is responsible for the safe operation and prolonged life of the battery. So that is one of the most research items in the electric vehicle. Thermal runaway of lithium ion cells can lead to explosions. Okay, so if we are not maintaining the thermal stability, the lithium ion cells can lead to explosions. Okay, BMS also estimates state of charge and state of health. Now your battery is there, which is showing 100% charge. So that is called a state of charge. State of health means what? Whether your battery is going to deteriorate or not. So that is the state of charge and state of health. Okay, it estimates remaining useful life, okay, and power of the battery, and performs cell balancing. Okay, so it estimates remaining useful life and it performs the cell balancing. So that is the important part of the BMS, and that is why we should go for BMS. Now, if you see the functions of BMS, okay, so it manages the energy in and out of the battery pack based on the state of charge and temperature. If temperature will be very high, the BMS will allow not to send the current out of the battery. Okay, it acts on safety related requests from other vehicle systems. Okay, it maintains the safety of the rechargeable energy storage system. It should ensure that the energy of the battery is optimized to power the load. So it will always try that the optimized power is transferred to the load. Okay, it should ensure that the risk of damaging the battery is very minimal. Okay, so the BMS should not allow to damage the battery. Okay, next is it should monitor and control the charging and discharging process of the battery. So it should monitor always the charging and discharging process of the battery. Okay, so you can just see this diagram. Okay, what we are doing it, this is a user interface, this is the electrical control, these are the safety protection, data acquisition, and we are measuring voltage, current, and temperature. So all these things, what we are doing it, we are measuring it, and we are understanding the battery management system. So these are the functions of the battery management system. Okay, now if you see this diagram, okay, so there can be a sensor system. Okay, this is a sensor system. So this is completely a hardware and this is completely a software. Okay, software part. So in the hardware part, you will be having a sensor which will sense the voltage, current, and temperature. Then it has safety circuitry also. It should have a charge control. It is managing the thermal stability. It is having a communication. It is having a switching and disconnection. So all the hardware part is there. In software part, we are measuring the state of charge and state of health. Okay, what is the present state of charge? What is we are managing the cell balancing. All the voltage among the cells should be managed. Then authentication and identification. Okay, fault detection. Okay, then user interface, history, what was their SOC long back. Okay, so that is the history or logbook functions we are using it. Okay, and these are the different work area of the battery management system. So it is measuring voltage, current, it is also optimizing it, it is measuring a state of charge, it is measuring state of health, it is making a cell balancing, it is also measuring the temperature, it is doing a communication, it is having a protection features. So these are the benefits of the battery management system. So what I'll request you that you should start researching on the battery management system, and this is a very good area of research where all the electrical, mechanical, electronics students and electronics students can do it. Even the computer science students or researchers can do in the battery management system. So type of cell balancing. So on basis of thermal management system, we are having passive cell balancing and active cell balancing. Okay. So on the basis of thermal management system, we are having a passive cell balancing as well as active cell balancing. Now I'll go in details about what is passive and what is active. Okay. So both active and passive cell balancing are effective ways to improve system health by monitoring and matching the SOC of each cell. So a battery is made of different cells. Okay. And now these different cells are connected in series and parallel. Okay. So each cell will be having different voltage level. So purpose of the cell balancing is to maintain the cell voltage so that inrush current will not flow and the battery will not be heated. That is the main purpose of the cell balancing. Okay. So we'll see, we'll understand with the help of this diagram. So this is the state of charge. Okay. You can just see. If I am making without balancing, see there are different cells in series. So without balancing, this is highly charged, this is less charged, and this is very less charge. You can just see here over here. In active balancing, what we are doing it, we are seeing this. So some part will come from here and some part will go to here. So this is called active balancing. Okay. Passive balancing means what? This is the lowest one. So this part will be converted into heat. Okay. It will be given into the register. It will be given to the register. So you see that in this is a passive balancing. Okay. This is the passive balancing. Okay. I'll give you a difference between active balancing and passive balancing. Okay. Now this is active balancing. What is active balancing? Charge moved from higher capacity to higher capacity cells. So I can move charge from lower capacity to higher capacity as well. Okay. And another way, what I can do, I can move higher capacity to lower capacity cells. So this is called the active balancing. Okay. Got a point? So here what we are doing it, we are using inductor and capacitor to store the charge and transferring back. Okay. But in passive balancing, what we are doing it, suppose this is a lower charge and this is the higher charge. We need to maintain the same charge of all the cells. So what I am doing it, this much amount of energy I am trying to pass to the register. So I am heating the circuit and I'm converting into this. So I'm maintaining this. So this is an unusable charge. And that is the comparison of a active and passive balancing. I hope you got it. If you have any doubt, you can just raise your hands and you can ask the questions. Now I'll go a little bit more details about passive cell balancing because my topic of discussion is passive cell balancing. So in passive cell balancing, what we are doing it, suppose this is 4.15 volt, 4.15, 4. So this is 1, 2, 3 cells are there. Okay. After using for some time, this becomes 3.65, this becomes 3.85, this becomes 3.75. This will create an unbalance. Okay, because this is having higher voltage and this is having lower voltage. So inrush current will flow and the battery can damage. So what we are doing, we are putting a resistors here. We are putting a resistors here. What is the purpose of this resistor? This resistor is taking the current and bypassing it through some MOSFET and heat is generated. So I am curtailing the this power through this resistors. So this is called a passive balancing. And finally, I am getting this part. Okay. So this is called a passive balancing. Okay. Got a point? So passive cell balancing is the simplest and cost effective method. It is very low cost, and all the BMS battery management system, which we can get it from China or some other countries, they are passive cell balancing because it is easier to accept it. It is easier to accept it, very cheaper. Okay. And just we are using a register. Okay. Registers and these registers are known as bypass registers. These registers are known as bypass registers. Okay, and each cells are connected in series. So each cells are connected in series, and in this way we are trying to remove the energy through these registers, bypass registers. Okay. Now I'll go to the active cell balancing. So in active cell balancings, I can charge or discharge. Okay. So suppose this is higher, so I am discharging here. Okay. This is higher, so I am discharging it. I am discharging it. Okay. How I am doing it? I am storing temporary energy to the capacitor. Okay. So if this has more charge, I am storing temporarily to this charge. Okay. And then I am releasing to this. Okay. If this is has lower charge. So in active balancing, the excess charge from one cell is transferred to another cell that has a low charge to equalize them. So what I'm doing it, I am making it to this, I'm making into this, I am making into this, and in this way I am maintaining a equal charge. Okay, got my point? So this can be done by charge storing components like capacitors and inductors. So this is about the active cell balancing. Okay. Now, if I go little bit more about the BMS, so BMS does the data gathering. I can measure the cell voltage and temperature, cell current, and I am making some diagnostic measurements. Then I'll make some calculations. So what I'll do, I'll measure SOC, a state of charge. I'll measure a state of health. Okay. I'll measure the power limit. I will balance, what is the balance is required. Okay, data verification. Then I'll make some analysis and judgment. Then I will make some control and communication. Okay, and then I'll make a power down or power up, and finally we'll make a recovery. So all these things we can do it with the help of a battery management system. So battery management system is, you can say that it is brain of the battery and brain of the electric vehicle, you can say that. Okay, how it is brain of electric vehicle, I'll go and I'll explain with the help of a next slide. Okay, so this is your BMS control unit. What I told, BMS can be two types, active and passive. Okay, but this is your BMS main control unit. Okay, it is trying to have a motor controller also. Okay, BMS. Okay, because it gives the information of the SOC, state of charge. Okay, got my point? It is also going to the display. It is giving what is the state of charge of a battery. Okay. It is also giving a safety device. Okay. It is also going to PC. Okay. Or it is going to cloud. Okay. Then this from battery pack, this BMS unit is there. Okay. Then it is also giving some cooling or heating elements. Okay. Voltage and current control. It is also giving supply to main or auxiliary charger. Okay. So these are the benefits of the BMS. Okay. So BMS has to be very correct, very perfect. Okay. Then only you can make the brain of the electric vehicle. Okay. Now, what we are doing it, you can just see here, any battery or any cell, we can measure voltage, current, and temperature. Only three things we can measure it. Okay. Because from a battery terminal, I can measure V, I can measure I can measure temperature. Only three things. This will pass to the cloud storage. Okay, cloud storage. Okay. So from this cloud storage, we'll try to find that what is the state of the health of the battery. Okay. And this state of the health of the battery will go to this smart BMS microcontroller. And this microcontroller, based on the state of health, it will say that this is the state of charge of a battery. Okay, got my point? So what we are going to do it, this SOH will be taken here, and we are going to use a machine learning method, okay, or deep learning method to predict the SOC and SOH and battery health parameters. Because suppose why this is required, you are going from suppose one place to another, and your electric vehicle is very new, and it is showing that you can go 100 kilometers. Okay, 100 kilometers. Now, after 1 year, if it says that it can go for 100 kilometers, but actually the battery state of health is not okay. So it means it can go only up to 80 kilometers. So you will be stuck in between. So for that, the state of the health of the battery measurement is very much required, and that is the talk of the day. Okay, and this is a very good area of research where you can go ahead. So what unique selling propositions we can achieve? It can be a cost effective, because I am using with some technology development, and once we are making a technology development, the cost can get reduced in due course of time. Okay, we'll make a prediction of SOC where I am including the aging life of the battery also. Then my BMS will be reliable, okay, and it will operate in safe operating envelope. Okay, safe operating envelope. Okay, and these are the things customer wants nowadays. Okay, it will be having a innovative content. Okay, it will be having a electrochemical modeling plus machine learning. Okay, and finally we'll come to a smart BMS for any lithium chemistry. It can be lithium ferrous phosphate, it can be NMC, it can be LCO, it can be LMO. So all type of chemistry we can use the same battery management system. That is the main idea behind my discussions today. Now, if you can see, we develop these things in our lab. Okay, so we are having a prismatic cells, then we are having a cylindrical cells of different types. We are having nickel strips. We make the PVC tubes. You can see that these are the holders. Okay, these are the spot welding machines, and here my student has made this battery pack. Okay, got your point? This is the BMS which we have developed. Okay, and this BMS has been open, and we have designed a larger battery pack of 74 volt 240 Ah battery pack in our lab itself. So you can just see that all the cells you can see over here, which are put in different racks. Okay, so this is a larger battery, and this battery, if you put it in an electric car, it will go for around 200 kilometers in one charge. Okay, and this is the charger. Okay, GB by T charger. If you have seen some electric vehicle, you will find that this charger is there. Okay, so the passive BMS at TRL4, which I'll continue. Okay, so this is the PCB layout my student has done it. Okay, so this is the PCB layout of the devices which we have done in our lab. Okay, everything. And once before PCB design, we have developed this in the EasyCAD software. Here we have made a simulation study that how these things will be there, how the registers value will be connected. All these things can be developed in our lab. Okay, then this is the hardware part. You can just see that this is the PCB part for one. This is the PCB part for one. And this is the passive balancing. When I say passive balancing, it is having resistors and MOSFETs. So here you can see that these resistance and MOSFETs are connected in series and parallel. And based on that, we have made some testing here. Just you can see that we have made a testing that it is a 48 volt, 48.9, 0.3 ampere current. So it is flowing it, and the BMS battery and is tested here finally. Okay. Now you can just see this is, we have opened it, because since we are doing at TRL4, so TRL4, we have made this battery management system, and it is working very fine. Now, how we have developed, so we have started with cells. Okay, just you can see here, cells are in series, and this series are connected in parallel strips, and all we have used it. We have done it in our laboratory. Okay. So battery type, we have used 18650 battery. What is 18650? This is the dimension of the battery. Okay, so it gives 2 ampere hour. Okay, got my point? So this is a cylindrical cells, and it is having its nominal voltage is 3.7. Its nominal voltage is 3.7. Charging voltage is 4.2. Means you can go up to 4.2 voltage, and minimum you can go for 2.7 voltage. So this is the cell configurations which we are getting it. Okay. Now we are charging the battery. When we are charging it, the battery, internal resistance is one of the most common causes of memory voltage drops towards the end of the charge. Then this is the cell balancing we are doing it. By charging it, you can just see that this is the state of charge, and this is the time axis. Okay, time axis. Okay, this is the state of charge. So all cells parameters we are checking it in the software. All the cells parameters we are checking in the softwares. Okay. So I hope you can see it. I feel some messages I received. So I'll just see if messages. Okay, okay. So it is not related to me. Okay. So this is the state of charge. You can just see how all the cells are balanced. Okay, and if you can see here, some is 58.12, some is 58.64, and later on with the help of passive balancing, we can make this things. So this is the Matlab design. We have made it in the Matlab design as well as you can see in the Matlab design, we have 48-volt battery discharge system is there. Then we are discharging it. Okay, we are discharging it. So the discharge phase of the battery pack begins when all cell voltages are above 2.8, okay, voltage, and the system is disconnected when a cell voltage in a battery pack falls below 2.7 volts. So this, we have discharged the battery and we have discharged the battery pack. Okay, this is the discharging phenomena which has occurred okay, throughout the time. So this also we have noted it down. Now the BMS which we have made it, this is a passive BMS working by transistors. So it has a BMS voltage of 48 volt. It has 13S, 13S means what? 13 in series. 13 cells are in series. Okay. So 13 series circuits, balance type BMS, we have balanced it, and it has also a over and under voltage protection. So all these things are existing in our the BMS which we have developed it. Okay, these are the EV chargers. With the help of these chargers, we have charged the battery, and we have adopted pulse charging methods. Okay, as a constant current and constant voltage method. This is, you can see that this is the car e-cart. This is the electronics load, from where we are loading the battery, and all these stuffs are there in our lab, electrical lab, research lab, where we are using the research of this quality. Okay, this is the net meter which we have developed it, and one of our students, Kratika Yadav and Amrit Pal Kaur, has developed this TRL 123, TRL 4 to 5, and TRL 5 to 9. Now we are planning to launch this. Okay, net metering. What is this net metering? This net meter is that when your electric vehicle is charging, this meter will read. But sometimes what will happen that you can sell your electric vehicle power to the grid. Okay, electrical grid. So when you are selling back to the grid, this net meter will read this power, So this will, what it means, that though you are sitting at home and your electric vehicle is idle, you are earning a lot. How you are earning it? You are charging during night time where the price of the electricity is low. And when you are discharging it, that time the grid is in demand, so you can sell power back to the grid. Okay, got my point? So this is the motto behind this net metering part, which we have developed it. Okay. Now this is the EV research lab at H Block in Thapar University. Here you can see all the stuffs are there. So we have developed approximately 2 crores of Indian rupees, means you can say that $2 million of approximately the equipments. Okay, 7 PhD students are presently working inside this lab. 15 UG students are working under different projects. Okay, 4 UG branch students are involved: electrical, mechanical, electronics, and computer science. Okay, so here 4 branch are there. Okay, one of our students did his projects from here, and he has been placed in Imperial College London, and he is doing his MS there. So this is the complete overview of my discussions, and with this I'll thanks, and the forum is open for the discussions if any questions session is there. Question is there.
Okay, thank you, Dr. Mukesh, that have presented about this article. So the article topic is electrical vehicle and IR 4.0. So I have made a mistake when I said that before. So the topic is about electric vehicle and IR 4.0. Okay. Before we go into the next session, also attend with us now, Dr. Waskito, the Vice Dean 1, Faculty of Engineering. Hello, Dr. Waskito. And some lecturer from mechanical department and from another department too. And thank you for joining us today. So we are so lucky Dr. Mukesh can attend with us today because this can give a change to our lecturer that will do the collaboration research with Dr. Mukesh.
Thank you, Sari.
Okay, before going to the next session, I will inform you that the topic that presented by Dr. Mukesh will be published in Teknomekanik Journal, and for the participants who have the similar research to it can access the article in Teknomekanik Journal website. And the absent link will be shared in the last season, and the certificate link will be shared in the Teknomekanik Journal website, and it will start tomorrow. So next we have question and answer session, Doctor. So we will give the
So
chance.
shall I leave the meeting and
you can close your yes.
Okay, I post I make it, Hannah.
So we will give.
No, this is done from my side, or if any questions, I'll love to hear.
Yes, we will ask the question from the participant. The participant can raise hand or write the question in the chat box.
And also you can share my email ID, Anna, if they need to ask any questions in future as well. In future as well, they can mail me, and I'll love to be giving the answers anytime.
Yeah, sure, Doctor. Maybe you can write your email address in the chat box.
Okay. So if no questions are there, so I'll shall I leave the meeting or for?
Maybe we can wait for a minute for the question.
Okay.
First.
Okay.
We have one question in the chat box, Doctor, from Tommy Satria Alas.
Okay, good. I got that question. One question is that how can we continue to be enthusiastic in research? See, research is something little bit challenging. Okay, and once you do the research in any of the area, it is challenging, no doubt, but you have to work hard. Okay, and research, when you are doing research, how you can be enthusiastic, you should learn first fundamentals. Okay, so fundamentals, if you know, you can just bridge the other parts. So suppose you are doing a research on something, you should work on the fundamentals. For example, I am working on the electric vehicle and I am working on the battery. So I should understand the electrochemical consideration of the battery. then I should go for electrical behavior of the battery. So fundamental is very much necessary for any research. So if you want to jump to the research of any topic, you should read and you should go ahead with the fundamentals. So that is from my side. Once fundamental is good, you can excel in your research and you will love to do the research. So that is the fundamentals behind your research.
The fundamental is important, Doctor, right? So, Bapak Tommy. Bapak Tommy. Okay, thank you, Bapak Tommy, for the question, for the first question. And the next participant who will give the question to Dr. Mukesh relate to the topic, you can raise your hand or write the question in the chat box. Or we can ask the question from Dr. Chris Madinata. Okay, we have the second question from Rahman Hakim. What is your motivation?
I have motivation to have research in this field. See, basically, I'm a researcher and I have made fundamentals behind this. And the electric vehicle is going to be the next transportation of the future. So since I am from electrical background, I thought that I should study the fundamentals of the electric vehicle, and this has motivated me. So if you want to stay in the research, you have to see the next generation research, and the next generation transportation is electric vehicle. So this is the motivation behind my research. And I'll be very helpful if you need any help in future. I love to give you the help related to my research fields and what we do it and how we motivate the students. All these things I can share you if you can mail me if you need in details.
Okay, Doctor, the third question in the chat box, I will share you.
Okay, is there any dynamic mathematical model of the active balancing? Yes, there are many mathematical model for the active balancing. Okay, so active balancing is very rarely used due to its high cost. So you can get a lot many papers in mathematical model and a dynamic mathematical model for active balancing. You have to understand the inductor and capacitors and how the inductor stores the temporary energy. So once you are having a inductor and capacitor, that can be modeled very easily with the help of dynamic mathematical model. Okay, so you can get you just type on the IEEE Explore, okay, where you can search some good papers. You just write mathematical model of active balancing, so you can get many research papers. And I too have some research paper. I can share you once you can mail me. I'll share you the research papers.
And also, I will inform you that the topic that presented by Dr. Mukesh will be published in Teknomekanik Journal, so you can access that in Teknomekanik Journal website. Dr. Chris have a question. Please, Doctor.
Okay. So what kind of popular power converter topology is employing to battery charger? So power converter topology is PFC based, है ना? And nowadays the people are using multi-interleaved device, okay, MIDBC. So the PFC based MIDBC chargers, they are employing it nowadays to reduce the power quality, to improve the power quality. So PFC based charger is mostly used, and for onboard charger, and for offboard charger, they are using the isolated PFC based charger.
Okay. Okay, Dr. Mukesh, which one is popular? For the fast charging, we use the 3-phase or single phase?
3-phase. For fast charging, it will be 3-phase because you need a higher amount of power. So the 3-phase is converted again into DC, okay, AC to DC, and then there is isolation is also required for charging. So we require 3-phase, 3-phase for the fast charging.
Okay, in India, when we visit to the IET Delhi, I look at one charging station. They use the 3-phase, right?
Right.
So what ampere the current flow to the charger?
See, charger means when you consider the charger, it is around 15 ampere, 3-phase. Okay, 3-phase. But when it goes to the battery, it is converting into 48 volt battery or 72 volt battery. So that time the current will increase. 440 volt AC into 15 ampere, okay, that is the input side. But when you are going to the battery, the current will increase. So in DC system, always the current will be higher.
Okay. And then in India, are the technology to implement bidirectional? At night, so the car fit to the current to the grid. Is it possible, or the India already implement this technology?
No, we are in testing phase. Okay, we are in testing phase in India. Few of the places like Delhi, then it is in Chandigarh also, and in India, then Mumbai, some parts are at the test bench where they are trying to transfer the power from the electric vehicle to the grid. Okay, so some part it is under test. It is under test.
So the technology vehicle to the grid or not, or still not popular in India?
No, it is not popular in any of the world for discharging to the grid. But charging is going on. Charging is going on throughout the India, and in US, you can say that California state is there, which are using more of the charging.
How about the implement the vehicle to the home already in India?
Yeah, vehicle to home, we have started it.
Okay.
Because already in India, inverter is there, inverter system, UPS system is there. So in India, the vehicle to home has started.
Okay. But when we implement vehicle to the home, so the home not connect to the grid, right? Or the home connect to the grid?
No, home is disconnected with the grid.
Or disconnect from the grid. Okay.
Yeah, disconnected from the grid. Okay,
Yeah.
there is a switch is there which will automatically disconnect it. Okay. As inverter, we are having inverter or UPS at home, so it automatically disconnects it.
Okay. So India have a regulation to implement the vehicle to the grid.
Yeah, we are making already. The regulation is started, and there is some norms are there. Whenever you are trying to power the power to the grid, so there is a distributed generation regulation is there, where a small power can be pumped to the grid. So that regulation.
How much we get the money if we send power to the grid compared to we get power from the grid?
That is the power money. It is not a rule in India for now being. What you can do it, you have to make a different purchase agreement. Okay, for example, in India there are many states are there, so each state has a regulation, so it will be decided based on the states. So when you are trying to give the power into the peak time, that time the cost is higher. And when you are
Okay.
taking power from the grid in the night, that time the cost will be lower.
Hmm.
So
Okay.
it
Okay.
depends upon the state to state.
Okay. Okay. Yeah. Implement the rule game, right? Implement the
Yeah,
rule
yeah,
game.
yeah.
Okay, thank you, Dr. Mukesh. You are sharing to
Thanks.
our university. Maybe the
Thank
next
you,
time
thank
I
you.
will to visit to Tapar. How
Okay,
about the
okay, sure,
how
sure.
about the Raffi? Raffi already finished?
Yeah, what?
Raffi
Ravi?
already finished his PhD?
Nee, he's about to finish, hai na? He's about to finish, hai na? Ravi Saruk is also there. This Binit has completed and he's in South Korea.
Oh, South
Then
Korea. Oh,
Binit, hai na? He's doing his postdoc. And Karanbir Dhingra has also completed. And
Karanpir already get postdoc?
yeah, he's doing his postdoc, hai na? Okay, in India itself. He's doing in India itself. And Kratika is there. She is completing. Amrit Pal Kaur paper has been accepted. One paper has been accepted, and in the
Supriya?
SCI. And
Supriya?
Supriya got married.
Got married, yeah.
Got married, and she is doing part-time PhD.
Part-time. Kartika got married, right?
Kratika also got married, and but she is working now.
Oh, okay.
She has not left. She has not left the PhD, but she is working right now.
Okay. Send my regard to them. I miss them. Maybe if the condition
sure.
is well, I will to visit all of you.
No, sure. You are most welcome, Anna. You are most welcome to India, Anna.
Okay. Thank you, Dr. Mukesh.
Thank you, Dr. Chris.
Thank you, Doctor. And we have 2 questions in the chat box, Doctor.
Okay. I'll just reply. From Arif Rahman, Anna, he has asked, in conjunction with the IR 4.0, what is contribution of research to the development of IR 4.0? Okay. So I told you that whenever you do a automation or artificial intelligence or machine learning to any of the research, that becomes IR 4.0. Okay, so that becomes IR 4.0. So you have to do a machine learning approach or automation system, and that becomes your IR 4. So in my system and battery management system, BMS, we are implementing the deep learning models and machine learning, and we are interfacing with the cloud. And this is making me to go for a IR 4.0. So this is the questions. Another questions by Ms. Swan. What made Tesla company decisions put their electrical business car India instead of Indonesia? As you know, in the beginning, Tesla will go to Indonesia for their business. So this is a political decisions, maybe political decisions, and Tesla is coming to India, but I think Tesla will come to each and every part of the country. It will visit to Indonesia as well. So they are in testing phase. So that is why they are trying to put in India. And these all are political decisions. Okay, and depends upon where you get a cheaper manpower and a cheaper technology, all these things. So this is a political decisions taken by government. But I'm sure that the Tesla is going to all part of the country. For example, you can say that Apple phone is all through the universe. So similarly, the Tesla is also going to be a good brand for electric vehicle, and it is going to come to each and every corner of the globe.
Okay, Doctor. Actually, I have one question. I have heard before that the BMS system has hardware and software system, if I'm not wrong. So which one has the most impact on BMS, the hardware or software?
See, both are having equal importance. Okay, both the system, hardware and software has importance. For example, with the hardware, we are trying to balance the power, but for the software is the brain. Okay, so if I say that heart is the hardware and software is the brain, so both has to work together. Both working in sync.
Okay, actually, my background is informatics and computer engineering. So, shall we do the research together about this topic? If you think,
Yeah, obviously the background, see, for BMS or any electric vehicle area, the information technology or computer science background is going to be one of the boost to the research. So always we have to make a interdisciplinary research nowadays. And any research, if you make a interdisciplinary, where you involve mechanical, where you involve electrical, where you involve electronics, computer science, information technology, okay, this will give a better research nowadays. So we have to involve all the type of discipline people so that we can get a very good product.
okay, I see. Also join with us today, the lecturer from mechanical department, also Dr. Regina. Um, he is a senior lecturer in mechanical department. You have a question, sir, maybe about this topic. And also my friend, Bapak Irwanto Zarmapitra. He is electrical department too. Maybe you have a question about this and maybe you have interest about this topic.
Mm, any questions you wanted to ask? Can you repeat? If any question, someone is there to ask the question.
Not yet, sir.
Yes. Okay.
Okay.
Please, Bapak Irwanto, if you have a question about this topic.
Maybe I have no.
Nay, I didn't get you. Can you repeat once again what you want the questions from me?
I'm sorry. Maybe I have no question because I've I have no questions.
Okay.
Thank you.
Okay. Okay. Thank you. Thank you. Thank you.
Maybe from the lecturer in mechanical engineering and another department. Also join with us Dr. Regina, Dr. Ariza, Mr. Henry, Mr. Dieta. Maybe you have a question and also interest with this topic. And also can ask about the research. What is the kind of the collaboration research we can do with Dr. Mukesh? Other participants that will wanna give a question about the topic, you can raise your hand or write the question in the chat box. Oh, we have one question from Rusli Aziz in the chat box, Doctor.
Okay. What is the biggest impact on developing electric vehicle, particularly to global warming? Is it will reduce the global warming in the future? Yeah, of course. The electric vehicle impact, if we are charging the electric vehicle from the grid, and grid power supply is coming from thermal or coal based or nuclear, then there is no any change in the global warming. But if we are introducing renewable energy sources, if we are putting a renewable energy sources into the grid and then we are charging the electric vehicle, it will reduce the global warming, because the global warming contributes, the transportation system contributes around 65%, okay, to the global warming. So if we are trying to reduce the global warming, we have to go for electric vehicle, and it will give it will further reduce to the global warming. So all countries, each and every country is pushing towards the electric vehicle.
Oke, bagi partisipan yang ingin mungkin bertanya dalam bahasa Indonesia, dipersilakan. Okay, doctor. I think there's no question more for the participants. I will say thank you so much that you have presented your article and agreed to submit your article in our Teknomekanik journal. This is the certificate.
Thank you.
For you.
Thank you very much. And I'll try to give more articles to your journal, and I love to associate with your university in future as well. And this has all happened due to Dr. Chris Madinata, who came to India and made a beautiful relations. And you all are invited to India. And whenever you are coming to India, you plan to visit Patiala, and it is a beautiful place, and you will enjoy. And in future, will try my level best to come to Padang once again, and will have a good research collaboration in future.
Okay, thank you, doctor. And I am so happy you can present your article here. And for the participant, the absent link have been shared in the chat box, and the certificate will be shared in the Teknomekanik Journal website. It's starting tomorrow. And for the Dr. Mukesh, maybe you can please stay in our Zoom, because we have more discussion about the collaboration research. And for the all participants, thank you for attending the 5th Symposium, International Symposium today. Oke, saya juga mohon izin kepada semua partisipan. Kami akan mengirimkan International Symposium yang ke-6, ya, akan mempromosikan International Symposium ke-6 yang pamfletnya akan dikirimkan ke WhatsApp dari masing-masing partisipan. Okay, I will say thank you to all participants who have attended today, and for all participants, thank you so much, and thank you for the lecturer from Mechanical Engineering Department and from other department from the other country, from Kazakhstan, Malaysia, India, and Timor-Leste. Thank you so much. And it is the end of our session, and you can leave the Zoom. Thank you so much. And for Dr. Mukesh and Dr. Chris Madinata, please stay in our Zoom, because we have more discussion about the research. Ya, bagi peserta, partisipan, karena acara kita sudah berakhir, jadi bagi para partisipan sudah boleh meninggalkan Zoom meeting kita hari ini. diharapkan untuk Bapak Kris, Bapak Syahril, Bapak Rahman, Ibu Sri Rizky untuk tetap di Zoom dulu karena kita akan berdiskusi lebih lanjut tentang penelitian.
Oke.
Silakan Pak Kris.
Ya, gimana Prof? Bu Sari?
Ya Pak, mungkin ada diskusi lebih lanjut yang tentang penelitian bersama
SOTK, PBK, tes sangat matang. Tes itu pasti ya akhirnya. Dulu pernah ada wacana, misalnya anak-anak yang tes masuk yang mandiri.
Apa agenda kita Sari?
Hasil SBMPTN.
Rencana diskusi lebih lanjut Pak, mungkin tentang penelitian yang bisa dilakukan dengan Dr. Mukesh ini Pak.
Oh banyak sih, cuma tapi Mbak polanya seperti apa? Keinginan Pak Saril seperti apa?
Teknisnya ya Pak. Assalamualaikum Pak Syaril, Prof.
Yap, Sari. Halo.
Halo.
Ya,
Prof.
Pak Kris.
Ya Prof. Kira-kira kolaborasi penelitian seperti apa yang kita harapkan dari Dr. Mukesh, Prof?
Wah, mantap Pak Kris. Jadi kalau bisa bangun kerjasama dulu, nanti baru riset kolaborasi.
Nah, ini bisa, saya siap saja bagi kuliahnya ke awak bisa jual katanya. Nah, cuma yang realnya apa kayak apa Prof yang apa yang awak inginkan gitu. Ini siap saya menampung malah
Bisa Pak Kris. Bisa menjadikannya dosen tamu dulu. Kemudian setelah itu kita bangun riset kolaborasi dengan Dr. Mukesh terkait dengan baterai ini. Indonesia nanti akan menjadi pasar terbesar dari baterai ini. Mungkin kita bisa ikut berkontribusi ya pengembangannya nanti di Universitas Negeri Padang. Kira nanti satu teknik mesin yang murni ini bisa menjadi apa istilahnya chance lapangan kerja terbaik ini.
Nah, ya.
Bisa berwirausaha di bidang baterai charging ini.
Nah, dulu juga bersedia Prof. Dulu, cuma dulu kita kan tahu anggarannya Prof. Mereka dengan Zoom kan mereka beliau bersedia bagi kuliah jarak jauh. Cuma anggarannya